At the edge of an international border, at the edge of the Pacific, at the edge of innovation, community, education, and discovery, you're listening to At the Edge of It All, a University of San Diego podcast where USD experts speak on topics and stories that impact you and the broader community.
Hello there, I'm Lisette Martinez.
And I'm Elena Gomez, and joining us on the podcast today is Dr. Susan Lord. She is a chair and professor of integrated engineering at the University of San Diego. Dr. Lord, thanks for being with us.
Thanks for having me.
You specialize in integrated engineering, and before we get into exactly what that is, we'd love to dive a little bit into your journey into why engineering? Why did you choose this as your career path?
I enjoyed lots of different topics when I was a student in high school. And when I got to my senior year, my dad said I had to be an engineer, but I could pick which kind. It did take me years to actually admit that that's the reason I majored in engineering, because I didn't think it sounded that great. But in retrospect, like his feeling was if you had the ability, engineering was a good career. And I do appreciate having someone who had faith in me, right? A lot of young people don't get that,
Right.
and so they don't consider doing it. So I went to Cornell, which has lots of other majors, because I figured if engineering doesn't work out, then I can do something else,
Yeah.
right? But then when I got there and saw what it actually was, it did resonate with a lot of things that I'm interested in. So like the electrical engineering part was sort of math for a reason, and I had always liked math, but was a little bit dissatisfied with like just getting the number 3. Like, what does that mean? So I liked the electrical piece where you kind of did math to see if like a light bulb would turn on or there's going to be too much power in a circuit or something. And then I took a material science class, and that was like chemistry for a reason. Things like how do you measure the spacing between atoms and stuff. And I thought that was really cool. And at Cornell, they had a program where you could do electrical engineering and material science. So from the beginning, I had an interdisciplinary perspective. And culturally, I also liked that because there were a lot of people in electrical, like 200 of us, but not very many women. And in materials, there were only maybe 20-some, but numerically maybe the same number of women. So electrical really couldn't have cared less if we were there, whereas materials was very excited to have us. So I
That's
felt much more
interesting.
welcome there, and appreciated just seeing those cultures. And I was very involved in the Society of Women Engineers, and so the materials experience plus the SWE experience helped me to feel more welcome than I might otherwise have. Then when I went to graduate school, I could do materials or electrical. So I chose electrical at Stanford, but there it was optoelectronics. So if you look at like lasers or photodetectors or those things, how do you make them? What's the materials you make them out of? And then how do you use them? So a lot of parts of engineering did fit well with me, but I don't know if I would have done it if I had not had my dad pushing me.
Was your dad an engineer?
My dad is a metallurgist, which is what we now call material science,
Uh-huh.
but taught physics for a long time at Drexel University in Philadelphia.
So let's get into the integrated engineering part of the conversation. What is that? If you can re-explain to us, I think every professor has their own way of explaining. We've talked to Dr. Hoople here before,
Yeah.
one of your colleagues, great conversation we had with him. What is integrated engineering to you?
So I think integrated engineering is an attempt to help students connect different things. So I believe that the technical is very important, but it needs to be in the context of social, environmental, economic in order to have an impact in the world.
Like the real world implications
Yeah,
of
that
it.
you can have a great technical solution, and we do have great technical solutions on things like maybe recycling or something, but if you can't convince other people to do it or or understand the implications it might have for other humans, then you're not able to actually solve problems because you're sort of stuck in your own little narrow silo. And so we're really trying to help students integrate, say, different kinds of engineering, integrate engineering with other disciplines, sociology, environmental science, biology. And also it's really important to me is integrate engineering with what you want to do with your life. In terms of your vocation, how you want to use your engineering skills or your talents in the world to help others, and how does the world impact you? And so for those who are ready to have that kind of conversation, I really do enjoy that. I want people to feel like they don't have to leave themselves at the door.
Right.
I mean, I often felt as a woman that I was supposed to like not talk about that or not have that come into play, but that does influence everything that I am and how I solve problems and all. So I really want my students to feel like, the other interests that they have, they're integrating those in with their identity as an engineer and how they're going to approach their practice of engineering in the world.
So why do you feel that this is such a growing field now? I'm sure back when you were studying too, as you just mentioned, you had those questions, you had those curiosities. What is it about the now that where integrated engineering is just really exploding?
I was at an international workshop last June, right around this time in London, with people integrating different sorts of things.
Right.
So it's growing. I think as people realize that the silos don't always work, think it's not a coincidence that most of the people at that workshop were women or people of color, because I think those of us who didn't ever quite fit right in are question maybe why that is and what could we do differently so that more people would feel welcome. I mean, when I was in graduate school, I was the only woman out of 25 people in my group, and it was just bad. I mean, people just treated me poorly on a daily basis, and I didn't understand why being a woman impacted my ability to do engineering. Like, it hadn't seemed that important before, but I was very involved in SWE, the Society of Women Engineers, so I was around a lot of women engineers. And so as part of being at Stanford, people would be like, what do women think? I'm like, I don't know. I don't know. Half the population thinks. I'm sorry, I'm the only woman you've seen all day,
Right.
but I'm a learner. That's just why it's good I'm a professor. So I went and took feminist studies classes, and that way I get to see other women and maybe learn what more women think.
Right.
But there was a whole different world. Like, I didn't know people studied those kinds of things, the wage gap or gender roles. Right. So it gave me a language and helped me really see a whole nother way of thinking about my own experience over in engineering, and helped me see that, a lot of my experience was mirrored in sexism, but also that it's connected to racism and all the other isms that we have. And really, a lot of it is the way engineering itself is done. And so rather than trying to fix myself or other people that were not white men, could we do something to help the engineering endeavor not be so painful? So I feel like a lot of my motivation in integrated engineering is to make it better for my colleagues and my students than I felt like it was for me.
One thing that you talked to us earlier about that I found interesting is that a lot of times students would enter engineering and they would do the courses, they would be taking the classes, they thought it was something that they wanted to major in, but then kind of felt a little bit of a hole of, well, I want to help people too, and I don't know how I can do that with engineering. Talk to us a little bit about that and how integrated engineering plays a really crucial part in solving that problem.
Yeah, so engineering, I believe, is done by, for, and with people. Like, we actually are solving problems for what people do. But I don't think you would know that from most of the engineering classes across the world, really, honestly. So part of what we're trying to do with integrated engineering is to help students see the larger context of what we're doing, which is often a little bit hidden. They think it's just the math, but then can we bring in some of the other things? The research shows that students may start out because they want to make a difference in the world, and then by their fourth year of engineering school, they're actually less engaged. They're less committed to that because they have not seen any of that. A lot of the classes tend to be very abstract, and there's a lot of math, but there's not a lot of application of that, and maybe very hard for students to see how they could use it more broadly. So one good thing about USD engineering is that we do take the same liberal arts requirements as everybody else on campus, which is unusual. But it doesn't mean our students take a second language, and they take ethics, and they take religion and philosophy. But our hope had been kind of before integrated is that they go take those things and then they figure out how to combine them. But that's hard. It's really hard. How do you relate sociology to engineering? So integrated engineering is partly, can we do that some with them? Can we have some examples in our class where we're trying to bring in the socio-technical? So the math is still there, the technical parts are still there, but what is the context in which they exist? And the hope is that for some students that will help them see, oh, this is how I could use this knowledge that I'm gaining, but to actually help people. And I think that disproportionately helps those who maybe didn't feel so welcome in the room or weren't so excited about the kinds of examples that we typically use. So that helps broaden things for them.
And the hope also is that teachers, professors know how to integrated engineering, right? So, and you receive an NSF grant to help you sort of formulate curriculum ideas for professors. Talk to us about that work.
Yeah, so I'm fortunate now I'm in this integrated engineering department where my students now are coming because they want some of this larger perspective, right? I had a student who came who was in mechanical, and she's like, I like mechanical engineering, but I feel like it's in a vacuum. Like, I think I need to understand how it's applied. So it's great. Like, well, come on over here. So my students are very excited about things when I try to bring in other topics. In fact, my students are like, how could there not be in a circuits class? How could you not talk about conflict minerals, which are the minerals inside your cell phone and things, and where they come from? But most students in electrical engineering throughout the country are not seeing that kind of stuff. So my NSF grant is partnering with a colleague at the University of Michigan. So my class has like 20 students, and they all think this is great. Her class has like 150 students, and not so sure they all think this is great. What we have seen so far is they don't hate it as much as people might have thought, right? They actually do say they think this is important, but they've never seen it before. right? And so now there are hundreds of students who at least know what a conflict mineral is, who wouldn't have before. So we try to take a technical topic, one of the learning objectives of the circuits class, the first class in electrical engineering, and tie it to something larger. So whether it's a capacitor that we usually learn, what are the equations that govern how it works? And then maybe if you're lucky, you have one in the back of the room in a drawer. But then we go the next step and say, where does it come from on the earth? And who are the people that are impacted by that? The conflict mineral one is fortunate because it gets into that whole idea of conflict minerals, and where most of those minerals come from is in the middle of Africa and the Democratic Republic of the Congo, which is where Wakanda is supposed to be. So I get to talk about Black Panther in my class, and we compare the mineral wealth there and how they hit it, right, with the mineral wealth of the real people in the DRC, but how they don't benefit from it, and we do. So usually, talking about Black Panther in your circuits class is automatically a win, right? And the students can certainly
get their
get
attention
motivated from that, and you get different people to want to respond and stuff. So the important part of that, so our goal is this is not for faculty who think this is a waste of time, but this is for faculty like, I would like to do this, but I don't know how, and I don't have time. So we do the research and we develop the modules for, say, a one class period thing where they have all the slides and homework problems and everything so that they could implement it themselves. And so our grant now is I've done things, my colleague has done some things, and we're just trying to get a larger group of people outside to do it in hopes that they will be able to at least provide something in their class where students see, oh, there's relevance to what I'm doing. And this is not, so far, stuff that a lot of students are familiar with. Almost all the students I've had have not seen it before. And I do love the comment of the student who's like, how could I be 20 years old and have never heard of this? And that's like the whole idea Africa has mineral wealth, like it's all of this stuff. So I think there clearly is a need for this. And then as they go forward and make decisions in the workplace, like if you don't even know about how this conflict is impacting people, of course you're not going to consider that as one of your design criteria. But if you know, and that's some of what I talk about with the students, then maybe you'll ask, right? And maybe as you're choosing a material for a capacitor, you'll pick the one that's not a conflict mineral.
Because at the end of the day, that's what it's all about, right? Engineering is supposed to be advancing humanity, but in responsible and ethical ways, right?
Yeah. So actually, if you use conflict minerals in the United States, the Dodd-Frank Act says you have to trace your supply chain. It is very difficult to do that because you're like literally getting this material out of the ground and putting it in a smelter and all this stuff. But they have to do these reports. So I have the students look at those reports and say, well, okay, what do you think of those reports? How clear are those reports? What would it be like if you were writing that report? Right? And what are some strategies that people are using to try to reduce the dependence on conflict minerals? All of this stuff is a little challenging because when I do a circuit, I can tell you the voltage at the certain point in the circuit, and there's no question about that. We all have the same answer. But if we understand about conflict minerals, like, do you need a new cell phone every year now that you know how it impacts people? Like, I don't have an answer for that. There's not one answer for that. I mean, I think that's why it's a real ethical issue. And when it's done well, they're like, oh, this is real world engineering. Right. But it is a little more uncomfortable because I, as the expert up there, can't just say, this is the answer and you need to follow me. It's, here's the questions we need to ask. Here's the kinds of things we need to think about. But I think that's more the real world too, right?
Well, I think that's also the reason why we should have more of different kinds of people in the field, right? Because you can pose a question, an ethical question to something being done, and you will get different answers and perspectives if there are different people in the room.
So I have, some students who are doing ethnic studies minors. They're very eloquent talking about things. I have another student who's like, why would that be that the people in the DRC wouldn't benefit from the mineral wealth? And someone else like, colonization. Have you heard of that?
Right.
Like, what does that mean? So there's a big range of different topics and things. And really, I think it's critical to have more voices in the room as long as those voices feel like they can say something.
Right.
Yeah, and that's something to go along with that. That is something that you've been sort of working towards in your classroom and in engineering, is creating a more diverse cohort of students, right? And it goes back again to sort of what you experienced as an engineering student and not wanting anyone else to feel the way you did, as one of very few women in your class, right?
Yeah. So
or as we like to describe here, Professor, is that inclusive excellence, right, in the classroom.
Exactly. Yeah. So how do we get as many people as possible to feel like they're welcome? Not everyone has to be an engineer. I'm fine with that. But I would like everyone to feel like it's an option for them and they would have a reasonable, they'd actually try it to see whether or not it works for them. And so Yeah, so I have been involved in numerous different things of trying to encourage all sorts of different folks. So the veterans grant that I did was fascinating to me to learn about these folks who've been, enlisted in the military and then chose to come to engineering, who bring all these assets, right? They're used to working with technology. They have a lot of experience in the field. They are great role models for many of our students, and they are very diverse on all kinds of reasons and things, which I think really adds a richness to our thing. I've also, worked I have a book on Latinas in engineering, or certainly women has always been a particular interest of mine, right? But it's not just women, it's people of color as well. Anyone who doesn't feel like they feel welcome. Can we help our curriculum so they maybe see themselves somewhere in it, see how this is relevant to them, and feel like their professor wants them to succeed and has confidence that they can succeed. I mean, engineering, one of my students years ago said, hard but not impossible. And I did like that. Like, you are going to have to work hard in my class. I'm not saying you don't have to do work. You can ask any of my students. But I believe you can do it. If you're in my room, you deserve to be there, and I believe you're capable of succeeding. So what can I do to help?
Well, the best things in the world are not easy to come by, to get, right?
Yeah.
Where do you see integrated engineering going, to sort of wrap up? You had this NSF grant where you're working on that curriculum. Not a lot of schools are maybe doing what we're doing here at the University of San Diego. What is your hope for integrated engineering, and where do you see it going in the future of kind of changing, I would assume, the way engineering is done in the workplace?
I mean, I'm very interested in changing the definition of sort of what counts in engineering and what doesn't. We do the conflict minerals module. One of the students is like, well, that conflict minerals module, that wasn't engineering, but it was really interesting. Well, I guess it was engineering. So like seeing students and faculty maybe change what counts in engineering and what doesn't. So I don't necessarily care if you call it integrated or not, but I would like to see engineering moving towards incorporating more of the socio-technical, more of the economic, more of the environmental, not just being so focused on the technical. I used to think I wasn't doing my job, like if I wasn't helping my students, say, analyze data. But if I had time, I'd get to these other things, right? But now I feel like I'm not doing my job if I don't help them understand some of the messiness of what the real world is, which is the integration with these other things. So I feel like if we want to attract and retain students, particularly a whole bunch of different kinds of students, engineering is so important, right? Think of the cell phone and how much that has changed our lives on a daily, minute-by-minute basis, right? So as we think about that, who is doing that? Is that a very narrow slice of the population? And are they being taught that the technical is the only thing? Right, that's rather terrifying, right? Because then you're not thinking about the other implications, which I think is very critical. And having people with different perspectives is critical to that, right? The example sometimes people use is the Chevy Nova, which means doesn't run in Spanish, and then you wonder why Spanish-speaking countries don't want to buy a car that says doesn't run. And it's not that it's a conspiracy. It's just no one on the team spoke Spanish, so they didn't think about that. No one that they tested it with spoke Spanish, so it didn't happen. So if we don't have other perspectives in the room, we don't make solutions that are as effective as they could be. And I think our students today really do demand more interdisciplinary. Like, that's what they are interested in. They want to connect different dots. It's the faculty that are usually the holdup, because that's not how we've been trained. So we're comfortable in our little silos. But then we're not really preparing them for what they need to go and do in the world, where I hope they will have an impact on a lot of these large issues that we really need to do a better job of. Our generation hasn't left it so great for the next generation, but hopefully the next generation will, see ways in which they can use a variety of different skills to address these problems.
Wonderful. Well, Dr. Lord, thank you so much for being here with us and sharing this knowledge.
Yeah, thank you for having me.
And if you like this episode, be sure to subscribe to catch our next one.